March 23rd, 1941, 14,000 feet over the English Channel. Flight Lieutenant James Parker felt his Spitfire shudder as he rolled inverted to track the Messerschmitt Bf-109 diving toward the convoy below. The morning sun blazed through his canopy, turning the cockpit into a greenhouse. Sweat ran down his face inside the leather flying helmet. His oxygen mask smelled like rubber and stale breath. Standard engagement. German fighter at 11 o'clock, diving fast, trying to strafe the British merchant ships hauling supplies from America. Those merchant ships were everything. Food, ammunition, aircraft parts, medical supplies, everything Britain needed to keep fighting. Parker's job was simple. Stop that Messerschmitt. Kill him before he kills them. Bring the Spitfire home in one piece. He checked his instruments one more time. Airspeed building, altitude dropping, oil pressure good, coolant temperature climbing but still in the green. His thumb rested on the gun button. 8 Browning .303 machine guns, 4 in each wing, loaded with a mix of armor-piercing, incendiary, and tracer rounds. 334 rounds per gun. That was it. No reloads at altitude. You made your shots count, or you went home with your tail between your legs. The Messerschmitt was maybe 800 yards ahead now. Close enough to see the mottled gray-green camouflage pattern on the fuselage. Close enough to see the black crosses on the wings. The German pilot hadn't spotted him yet, too focused on the convoy below. Classic mistake. Tunnel vision gets you killed in air combat. Parker pushed the stick forward. The Spitfire's nose dropped hard. Negative G forces lifted him against his harness straps. His stomach lurched. Everything loose in the cockpit floated upward. And then it happened. The thing that had killed 14 of his squadron mates in the past 6 weeks. The thing every British pilot feared more than German guns. The Rolls-Royce Merlin engine coughed once, twice, then died completely. 1.5 seconds of silence. 1.5 seconds where the propeller windmilled uselessly through the air. 1.5 seconds where Parker was a 6,000-pound glider instead of a fighter. 1.5 seconds where the Messerschmitt would get away, where the convoy would get hit, where men would die because his engine had betrayed him. Parker's training took over. Instinct from hundreds of hours in the cockpit. He eased back on the stick, reducing the negative G forces. Sometimes that helped. Sometimes the fuel would slosh back to where it needed to be, and the engine would catch. Sometimes you got lucky. But this time, something different happened. Something Parker had never experienced before in 9 months of combat flying. The engine caught again immediately, roared back to life, full power, 1,200 horsepower, shaking the entire airframe. No hesitation, no flooding, no carburetor failure, no praying and hoping and fighting with the controls while a German fighter circled back to kill you. Parker didn't understand it, didn't question it, he just squeezed the trigger. 8 Browning machine guns opened up. 300 rounds per second streamed toward the Messerschmitt. The German pilot never saw it coming. His aircraft disintegrated. Pieces tumbled toward the channel. Parker pulled up, scanned the sky, and keyed his radio. Tango leader, this is Tango 3. Splash 1 bandit. Engine performed perfectly. Silence. Then Squadron Leader Davies's voice crackled back. Say again, Tango 3. Your engine worked during the dive? Affirmative. No cutout. No hesitation. Like someone fixed the bloody thing overnight. Someone had. Her name was Beatrice Shilling, and she'd installed an unauthorized modification in Parker's Spitfire 14 hours earlier. A brass washer that cost 50 cents to manufacture. A simple piece of metal that would save 3,000 Royal Air Force pilots over the next 3 years. A modification so effective that pilots would name it after her, mechanics would worship her, and German fighter pilots would curse her name. This is the story of how one woman's engineering genius turned the most frustrating weakness of British fighters into their greatest tactical advantage. How desperation led to innovation. How a 50-cent solution beat $1 million problem. And how the Battle of Britain was won not just by brave pilots, but by a 32-year-old engineer who refused to let her boys die. Let's go back to where this started. July 1940. The Royal Air Force had just upgraded to 100-octane fuel. Higher octane meant more engine boost. More boost meant 1,310 horsepower from the Merlin. Instead of 1,100, Spitfires could suddenly hit 370 miles per hour in level flight, fast enough to catch Messerschmitt Bf 109 seconds. Fast enough to intercept German bomber formations before they reached London. But there was a problem. The Skinner's Union carburetor, the device that mixed fuel and air for the Merlin engine, couldn't handle high-speed combat maneuvering. Specifically, it couldn't handle negative G-forces. When a Spitfire or Hurricane pushed into a sudden dive to attack, fuel surged to the top of the float chamber. The jet starved. The engine quit for 1.5 seconds. 1.5 seconds doesn't sound like much, but in air combat at 300 miles per hour, 1.5 seconds meant the difference between life and death. In that time, a Messerschmitt could close 300 yards and open fire. German pilots knew about the problem. They exploited it ruthlessly. The tactic was simple: fly straight and level, wait for a British fighter to dive on you, then turn hard when their engine quit. The British pilot would be fighting desperately to restart his engine while you circled back and put bullets through his cockpit. 14 Hurricanes had gone down that way in 6 weeks. 9 Spitfires. 23 of Britain's best pilots dead because their own engines betrayed them. The Germans didn't have this problem. Their Daimler-Benz engines used direct fuel injection. No float chamber, no flooding. Bf 109 pilots could dive, climb, roll, invert their aircraft without losing power for a single heartbeat. It gave them a decisive advantage in every engagement. Now, before we go further into this story, I want you to do me a favor. If you're sitting here listening to this, thinking about those young guys climbing into Spitfires every morning, knowing their own engines might kill them before the Germans got a chance, hit that like button. Because this story needs to be heard. These people deserve to be remembered. And your like tells the algorithm to show this to more folks who need to hear it. It's that simple. One click. Huge difference. All right, back to 1941. Beatrice Shilling stood on the tarmac at Royal Air Force Kenley, watching pilots climb into their fighters for morning patrol. She was 32 years old. 6 years at the Royal Aircraft Establishment. 0 solutions to the problem that was killing her pilots. Let me tell you about Beatrice Shilling, because she wasn't your typical engineer. Hell, she wasn't your typical anything. She grew up in Hampshire, working-class family. Father was a carpenter who built furniture during the week and repaired motorcycles on weekends for extra cash. Beatrice spent her childhood in that workshop, watching her father's hands work. She learned that machines were logical, predictable. You could understand them if you paid attention. You could fix them if you had the patience. At 14, she bought her first motorcycle with money she'd saved from odd jobs. A Norton. 4-stroke, single-cylinder, 5 to 100 cubic centimeters of temperamental British engineering. Most girls her age were learning to dance, practicing piano, preparing for marriage to some local boy who'd work in the same factory as his father. Beatrice was different. She wanted to understand how things worked, why a piston moved, how a camshaft controlled valve timing, what made an engine produce power. She stripped that Norton down to individual components on her father's workshop floor, took it apart, piece by piece. Crankshaft, connecting rod, piston, valves, camshaft, carburetor. She cleaned every part, measured every tolerance, understood how each component contributed to the whole. Then she rebuilt it, not because it was broken, because she needed to know. By 16, she was modifying that Norton. Better carburetor jets for improved fuel mixture, different exhaust pipe for better flow, lighter flywheel for faster acceleration. She made it faster, made it more reliable, made it hers. At 18, she entered her first motorcycle race, Brooklands Circuit, the most famous racing venue in Britain. A concrete banking where motorcycles and cars pushed the limits of speed and courage. The organizers didn't know what to do with her. A woman? Racing? Motorcycles? Against men? It wasn't done. It wasn't proper. They almost didn't let her enter. She finished third in her first race, beat 17 men. Some of them had been racing for years. She'd been racing for exactly 1 day. By 25, she'd become one of the fastest motorcycle racers in Britain. She raced that same Norton, the one she'd bought at 14, the one she'd rebuilt a dozen times. She knew every bolt, every bearing, every characteristic quirk of that machine. She averaged 106 miles per hour at Brooklands, fast enough to earn the British Motorcycle Racing Club Gold Star. Only 3 women in history had earned that award. Beatrice was the second. Racing taught her something crucial that laboratory work never could. She learned how engines failed under stress, high G turns where centrifugal force tried to throw fuel away from where it needed to be, sudden acceleration where the fuel mixture went lean and the engine threatened to seize, extreme lean, angles where oil pressure dropped and bearings screamed for lubrication. She learned to feel what an engine needed before the gauges told her. That intuition, that connection between human and machine, that made her the best carburetor specialist in Britain. But more importantly, racing taught her about acceptable risk. Every time she threw her leg over that Norton and rolled onto Brooklands Circuit, she was gambling with her life. One mistake at 100 miles per hour and you didn't walk away. You got scraped off the concrete and buried in a closed casket. She understood that some risks were worth taking, that sometimes you had to bet everything on your own judgment. That lesson would serve her well in March 1941. In 1935, she earned a degree in mechanical engineering from the University of Manchester. One of maybe 20 women in the entire country with that qualification, the male students didn't know what to make of her. Some ignored her, some helped her, some resented her for invading their territory. She didn't care. She was there to learn, not to make friends. Her professors recognized her talent immediately. She understood thermodynamics better than students who'd been studying it for years. She could look at an engine diagram and see inefficiencies that others missed. She could calculate heat transfer rates in her head while other students struggled with pencil and paper. She graduated at the top of her class. She joined the Royal Aircraft Establishment in November 1939, 1 month after war was declared. She was one of 2 women in the engine department. The other woman was a secretary. Most of the men she worked with had never met a female engineer. Some of them didn't believe women belonged in engineering. Beatrice didn't care what they believed. She cared about keeping pilots alive. By March 1941, she'd spent 11 months working on the carburetor problem. The engineering teams at Rolls-Royce were designing a proper solution, a pressure carburetor, a complete redesign of the fuel delivery system. But the pressure carburetor wouldn't be ready until 1943, maybe 1944. The war wouldn't wait. The pilots couldn't wait. Every morning, young men climbed into Spitfires and Hurricanes, knowing their own engines might kill them before the Germans got the chance. The solution came to Beatrice in January 1941. Simple physics. The float chamber flooding happened because fuel could flow unrestricted when gravity reversed. What if you restricted the flow? Not completely, just enough to prevent flooding. The engine would still get fuel, just not too much fuel. A brass disc with a precisely calculated hole in the center. Install it in the fuel line before the carburetor. Limit maximum fuel flow to slightly less than what the engine demanded at full throttle. She machined the first restrictor herself in the Royal Aircraft Establishment workshop. Brass, thimble-shaped, 0.125 inches in diameter. The hole in the center was 0.04 inches. Those dimensions mattered. Too large, and the carburetor would still flood. Too small, and the engine would starve at full power. She tested 17 different sizes before finding the right one. Then she simplified the design. A flat washer was easier to manufacture, easier to install, easier to replace if damaged. Bench tests showed it worked. The restrictor prevented flooding during simulated negative G conditions. But bench tests weren't combat. Combat was 300 miles per hour. Combat was negative G forces strong enough to pin a pilot against his harness. Combat was life or death in 1.5 seconds. She needed to test it on an actual aircraft under actual combat conditions. The problem was getting permission. Installing unauthorized modifications on Royal Air Force fighters violated about 40 different regulations. If the restrictor failed in combat and a pilot died, Beatrice would be court-martialed, maybe imprisoned. She decided to skip permission and ask forgiveness later. That morning at Kenley, she had 6 restrictors in her leather satchel and one very cooperative ground crew sergeant who owed her a favor. Sergeant William Cooper had worked on Merlin engines for 3 years. He'd seen 19 pilots die from engine failures. He didn't ask questions when Beatrice showed him the brass washer. He just nodded and reached for his toolkit. Squadron Leader Davies's Hurricane sat on the dispersal pad. Pilot inside, engine warming up, 20 minutes until takeoff. Cooper worked fast. He disconnected the fuel line between the pump and carburetor. The restrictor slid into place. He welded it with a small butane torch. 60 seconds of work. The modification was invisible unless you knew where to look. Beatrice checked the weld. Clean, solid, professional. Davies would fly with the restrictor. He didn't know it was there. Beatrice hadn't told him, hadn't told the squadron commander, hadn't told anyone except Cooper. If the restrictor failed and Davies died, there would be no paper trail, no authorization forms, no testing documentation, just a dead pilot and a brass washer that shouldn't have been there. The Hurricane's Merlin engine roared to full power. Davies ran through pre-flight checks. Oil pressure good, coolant temperature good, magnetos firing on all 12 cylinders. He released the brakes. The Hurricane rolled forward, gathered speed, lifted off. Beatrice watched it climb. 800 feet, 1,200 feet, 2,000 feet. The Hurricane banked south toward the channel. She'd brought a pair of binoculars. She watched Davies climb to 15,000 feet. 2 more Hurricanes joined him, a section of 3. Standard patrol formation. They flew toward Dungeness. German fighters had been active over Dungeness all week. If Davies encountered a Messerschmitt, he'd have to dive, and the restrictor would either work or it wouldn't. Beatrice waited on the tarmac. Cooper stood next to her. Neither of them spoke. 40 minutes passed. An hour. Radio silence from Davies's section. That could mean anything. No contact with enemy fighters. Or contact so intense there was no time to report. Or Davies was dead and his Hurricane was scattered across a French field. At 9:37, the radio crackled. Controller's voice. 3 Hurricanes inbound, 2 minutes out. Beatrice raised the binoculars. She saw them. 3 dark shapes against the morning sky. All 3 aircraft. No losses. The Hurricanes entered the circuit. Davies landed first. He taxied to dispersal, cut the engine, climbed out. Beatrice walked toward him. Her hands were shaking. She'd designed bombs before. She'd tested engine modifications under laboratory conditions. She'd never done anything like this. Never installed an unauthorized modification and sent a pilot into combat to test it. Davies pulled off his helmet. He was smiling. That was unusual. Pilots didn't smile after combat patrols. They usually looked exhausted, haunted. Davies looked excited. Cooper asked the question, "Any problems with the engine, sir?" Davies looked at Cooper, then at Beatrice, then back at Cooper. "Best the Merlin's ever run?" he said. "Dove on 2 Messers over Dungeness. Engine never missed a beat." Beatrice asked Davies to describe exactly what happened. He'd spotted 2 Messerschmitt Bf 109 seconds at 14,000 feet, both aircraft flying east toward France. Davies had positioned his section above them, altitude advantage. He'd pushed into a steep dive, 400 miles per hour, negative G forces strong enough to lift him against his harness straps, the dive that should have killed his engine. But the Merlin kept running. Full power through the entire dive. Davies had closed to 200 yards before the German pilot saw him. He'd fired a 3-second burst, saw strikes on the Messerschmitt's wing root. The German fighter broke hard right and fled toward France. Davies had pulled up, climbed back to altitude. The engine had performed flawlessly. It was the first time in 11 months that Davies had successfully pressed a diving attack without his engine cutting out. He wanted to know what maintenance had done to his Hurricane. Beatrice told him. She explained the restrictor, the brass washer, the fuel flow limitation. Davies stared at her for 5 seconds. Then he turned to Cooper. "Put that thing in every Hurricane on this station," he said. "Today," Beatrice explained, "it wasn't authorized." Davies didn't care about authorization. He cared about surviving combat. Every pilot at Kenley had lost friends to engine failures. 19 pilots dead in 6 months. Davies said if the brass wanted to court-martial him for installing an unauthorized modification, they could do it after the war. Right now, his squadron needed working engines. Cooper installed restrictors in 4 more Hurricanes that afternoon. Beatrice had brought 6. She kept one for testing. 5 Hurricanes flew combat patrols with restrictors over the next 3 days. 0 engine failures. 12 diving attacks, successfully pressed against German fighters. Pilots reported the Merlin engines ran perfectly. Better than perfectly. Some pilots claimed they were getting more power at altitude. Word spread fast. By March 18th, every squadron commander in 11 Group knew about the restrictor. They wanted it. All of them. Immediately. Beatrice received 14 phone calls in 2 days. Could she come to their stations? Could she bring more restrictors? How fast could they be manufactured? Now listen, if you're still with me here, do me another favor. Hit that subscribe button. Because we're about to get into the part where this little brass washer changes the entire course of the air war over Europe. And if you like hearing about the real heroes of World War II, the ones who don't get Hollywood movies made about them, this channel is for you. We dig up these stories, we tell them right, and we make sure these folks don't get forgotten. Subscribe so you don't miss the next one. The problem was supply. Beatrice had machined 6 restrictors herself in the Royal Aircraft Establishment workshop. Manufacturing thousands would require proper production facilities, brass stock, precision machining equipment, quality control. She needed approval from the Air Ministry. She needed funding. She needed time. She got approval in 4 days. The Air Ministry fast-tracked her proposal. A war-winning modification, they called it. Rolls-Royce received the production contract. They could manufacture 500 restrictors per week. Installation would begin immediately at every fighter station in Britain. Beatrice assembled a small team. 3 engineers from Farnborough who understood carburetor systems. 2 civilian mechanics who'd worked on Merlin engines since the prototype days. They would tour Royal Air Force stations and oversee installation. The restrictor could be fitted without removing aircraft from service. That was critical. Every Hurricane and Spitfire needed to stay operational. The Battle of Britain was technically over, but German fighters still crossed the Channel daily, sometimes alone on reconnaissance missions, sometimes in groups hunting for convoys, sometimes escorting bombers targeting British cities and ports. Royal Air Force Fighter Command couldn't afford to ground its squadrons for maintenance. Beatrice loaded her Norton motorcycle with tools and restrictors. She'd visited 43 Royal Air Force stations before the war, back when she was testing fuel systems for different altitude conditions. She knew every fighter base in southern England. She knew the commanding officers, their temperaments, their priorities. She knew the ground crews, the men who kept fighters flying through 14-hour workdays. She knew the sergeants who actually ran the maintenance operations, while officers took credit. She knew where to find cooperation and where to expect resistance. Now she'd visit them again, this time with a brass washer that would save their pilots. By March 25th, installation teams were ready. 600 restrictors manufactured by Rolls-Royce to Beatrice's exact specifications. 40 stations on the schedule. 3,000 Merlin engines waiting for modification. Every Hurricane and Spitfire in fighter command. Every operational aircraft. Every training machine. Every reserve fighter sitting in a hangar waiting for a replacement pilot. All of them needed the restrictor. All of them would get it. Beatrice started her Norton and headed north toward Biggin Hill. The ride took 2 hours through Surrey countryside. Spring morning, temperature in the 50s, light wind, perfect riding weather. The Norton ran beautifully. 4-stroke single-cylinder engine, humming at 60 miles per hour. Beatrice always thought better on a motorcycle. Something about the speed, the focus required, the connection between rider and machine. Problems that seemed impossible in a laboratory became solvable at 60 miles per hour on a country road. She thought about the restrictor as she rode, thought about all the things that could go wrong. The brass could crack under thermal stress. The weld could fail under vibration. The hole could become clogged with contamination. The fuel flow might be too restricted at high altitude, where air was thin and engines demanded maximum fuel. Any of these failures could kill a pilot, could kill multiple pilots, could make the problem worse instead of better. But the alternative was doing nothing, letting pilots die from a problem she understood and could fix. That wasn't acceptable. Biggin Hill was the busiest fighter station in 11 Group. 32 Spitfires, 21 Hurricanes, 4 squadrons rotating through continuous combat operations. The station had been bombed 6 times during the Battle of Britain. The operations building still showed damage from a near miss in September. Shrapnel scars pockmarked the brick walls, windows patched with plywood, one corner of the roof covered with tar paper where German bombs had torn through. But the station was operational. Fighters took off and landed constantly. Ground crews worked on aircraft in the open dispersal areas. Fuel trucks moved between revetments. Armament crews loaded machine gun belts and cannon ammunition, the controlled chaos of a fighter station at war. Beatrice arrived at 8 in the morning on March 26th. Station Commander Group Captain Grace met her at the gate personally. He was 53 years old, career Royal Air Force, fighter pilot in World War I. He'd flown Sopwith Camels over the Western Front in 1918, shot down 7 German aircraft, earned the Distinguished Flying Cross, and survived the war. Now he commanded a fighter station and watched young men die from problems that shouldn't exist. Grace had lost 7 pilots to engine failures in the past 2 months. 2 died in crashes after their engines quit on final approach. 3 died in combat when their engines failed during critical maneuvers. 2 more survived engine failures but were so shaken they requested transfers to other squadrons. Grace wanted the restrictors installed immediately, wanted them in every aircraft, wanted his pilots to have reliable engines. "Miss Shilling," he said, shaking her hand with the firm grip of someone who respected competence regardless of gender. "I've read your technical report. Brilliant work. Simple, effective, implementable. Everything good engineering should be. How soon can you get them installed?" "Ground crews are ready?" Beatrice asked. "Waiting for your instruction." "Then we start immediately. 4 aircraft at a time, 12 minutes per installation. All 53 Merlin engines completed within 2 days." Grace smiled. "I knew I liked you. My pilots have been asking about this modification since Davies reported it at Kenley. They're ready. Let's give them reliable engines." The ground crews worked in shifts, 4 aircraft at a time, positioned in the maintenance hangar. Each installation followed the same procedure. Disconnect the fuel line between the pump and carburetor, clean the connection points, slide the restrictor into place, weld it with a small butane torch, reconnect the line, test for leaks, verify proper flow, sign off the maintenance log, move to the next aircraft. The welding had to be perfect. A faulty weld at 15,000 feet could starve the engine completely. The restrictor would become a blockage instead of a flow limiter. The engine would quit from fuel starvation. The pilot would have no warning. One moment full power, the next moment silence. Beatrice supervised every installation personally. She checked every weld with a magnifying glass, tested every connection with pressure gauges, rejected 3 restrictors that didn't meet specifications. Better to delay installation than to send a pilot up with faulty equipment. Pilots watched the modifications with intense interest. They gathered around the hangar, smoking cigarettes, drinking tea from chipped mugs, asking questions. They wanted to understand what this little brass washer did, how it worked, why it would solve their problem. Flight Lieutenant James Lacey had 41 combat missions. He'd experienced engine failure twice, both times during critical moments in dogfights. The first time, he'd been diving on a Messerschmitt Bf 109 over Dover. His engine quit at the worst possible moment. The German pilot saw his predicament, circled back, and put bullets through his Spitfire's tail section. Lacey barely made it home. The second time, he'd been engaging a Heinkel bomber over the Thames estuary. His engine quit during the attack run. The bomber's defensive gunners had target practice. They put 37 bullet holes in his Spitfire. Lacey survived through pure luck. One round had passed through his canopy 3 inches from his head. He asked Beatrice how a simple washer could solve the complex carburetor problem. She explained fuel flow physics using terms a pilot could understand. Your carburetor has a float chamber, like a toilet tank. Fuel flows in, maintains a specific level. When you push into -G, gravity reverses. The fuel surges upward. The float rises. The needle valve closes. The jet starves. The engine quits. Simple physics, brutal consequences. Lacey nodded. And this restrictor prevents that? Limits the fuel flow to just below what the engine demands at maximum power. The float chamber can't flood because fuel can't flow fast enough to overwhelm the system. The engine gets 95% of maximum fuel delivery, but it gets it consistently, even during -G maneuvers. What's the cost? What do we lose? 5% maximum power at full throttle. You won't notice it in combat. The difference between 1,310 horsepower and 1,245 horsepower at altitude is negligible, but you gain 100% reliability during diving attacks. Lacey understood immediately. He was an engineering graduate from Cambridge. He'd studied thermodynamics and fluid mechanics. He knew the math. Brilliant simplicity, he said. Trade 5% theoretical maximum power for absolute reliability. Nobody operates at maximum power continuously anyway. We'd burn up the engine in 10 minutes. He turned to his squadron mates watching nearby. Gentlemen, Miss Shilling just solved our problem. Our engines will work like German engines now. Direct fuel injection without the complexity. Simple, reliable, deadly. This changes everything. By March 28th, all 53 Merlin engines at Biggin Hill had restrictors installed. Every Hurricane, every Spitfire, every operational aircraft, every training machine, all of them modified, all of them reliable. Beatrice moved to Hornchurch, then Northolt, then Tangmere, then Duxford, then North Weald, then Kenley again. The pattern repeated at every station. Ground crews worked 12-hour shifts. Mechanics welded restrictors until their hands cramped. Quality control inspectors checked every installation. Pilots flew combat patrols with modified engines. 0 failures reported. 0 engine quits during diving attacks. 0 pilots dying from preventable carburetor problems. The restrictor worked exactly as designed, better than designed. Some pilots reported improved performance at high altitude. Beatrice suspected this was psychological rather than mechanical. Confidence in equipment translated to more aggressive flying. More aggressive flying translated to better combat results. But she didn't discount the reports. Whatever gave pilots confidence was worth pursuing. Pilots started calling it Miss Shilling's Orifice. The nickname came from Sir Stanley Hooker, chief engineer at Rolls-Royce Supercharger Division. It was crude British humor, slightly inappropriate. Beatrice didn't mind. She'd spent 6 years working with Royal Air Force personnel. She understood how military men dealt with stress. If crude nicknames helped them remember the modification, she'd accept any name they wanted to use. The nickname spread faster than the restrictor itself. By April, every pilot in Fighter Command knew about Miss Shilling's Orifice. They requested it specifically. Some pilots refused to fly combat missions until their aircraft had the modification installed. Squadron commanders supported them. They'd seen too many good pilots die from preventable engine failures. German intelligence noticed the change in British fighter performance immediately. Luftwaffe, after action reports from early April, mentioned improved Royal Air Force diving attacks. British fighters no longer broke off pursuit during negative G maneuvers. They pressed attacks all the way through the dive. They committed to engagements that would have been suicidal a month earlier. Messerschmitt pilots could no longer exploit the carburetor weakness. The tactical advantage that had defined aerial combat over Britain for nearly a year had disappeared overnight. German fighter pilots reported the change in debriefings at their bases in France. The British weren't flying differently. They weren't using new tactics or formations, but their engines worked differently, reliably, consistently. Like German engines with direct fuel injection, the Messerschmitt Bf 109 pilots had enjoyed a decisive advantage since the Battle of Britain began. Now, that advantage was gone. British Spitfires and Hurricanes could dive just as aggressively as German fighters, could maneuver just as violently, could exploit opportunities that would have been impossible before. Luftwaffe intelligence officers interrogated captured Royal Air Force pilots, looking for information about the change. The pilots knew about the restrictor by then. Most of them called it Miss Shilling's orifice. They explained the modification with pride. A British woman engineer had solved the problem. A simple brass washer, 50 cents of metal, installed in every fighter in the entire Royal Air Force. The German intelligence officers didn't believe it at first. A brass washer solving a complex fuel delivery problem? Impossible. There had to be more to it. New carburetors, fuel injection systems, something complicated and expensive. But when they examined captured British fighters, they found it. A simple restrictor welded into the fuel line. Basic engineering, elegant simplicity. The Germans had been working on complex pressure carburetor designs. The British had solved it with a washer and a welding torch. Now let me tell you about March 23rd, 1941, the day everything changed. The day 12 pilots discovered what British fighters could really do when their engines worked the way they were supposed to. Flight Lieutenant James Parker wasn't the only pilot flying with the restrictor that morning. His entire squadron, 609 Squadron based at Warmwell, had received the modification 2 days earlier. 12 Spitfires, 12 brass washers, 12 pilots about to make history. The mission briefing was standard. Group Captain Harris stood at the front of the briefing room with a map of the English Channel spread across the wall. Red markers showed enemy positions. Blue markers showed friendly forces. Projected flight paths drawn in grease pencil. Intelligence estimates. Weather forecasts. The usual pre-mission routine that every pilot knew by heart. "Gentlemen," Harris began, "German bomber formation spotted over Cherbourg at 0630 hours. Estimated strength, 18 Heinkel. He, 111 bombers. Escorted by 20 Messerschmitt Bf 109 fighters. Current heading, northeast. Target appears to be Portsmouth Naval Facilities or the convoy currently 20 miles south of the Isle of Wight. Either way, we're not letting them through." He tapped the map with his pointer. 609 Squadron will intercept here, approximately 30 miles south of Portsmouth. You'll have altitude advantage. Use it. Hit the fighter escort first. Break up their formation. Once the bombers lose their cover, they're sitting ducks. Questions? Flight Lieutenant David Morrison raised his hand. "Sir, what about engine reliability? Half of us have experienced carburetor failures in the past month during diving attacks." Harris smiled. It was the first time Parker had seen the station commander smile in weeks. "That's why we're having this conversation. Every Spitfire in this squadron received a modification 2 days ago. A fuel restrictor designed by Miss Beatrice Shilling at Farnborough. Bench tests show it prevents carburetor flooding during negative G maneuvers. But these will be the first combat trials. You men are guinea pigs." "Congratulations." Morrison didn't look reassured. "Sir, are you saying our engines might still fail?" "I'm saying they shouldn't fail. The engineering is sound. But this is combat, not a laboratory. Stay alert. If your engine quits, you know the drill. Ease back on the stick, reduce negative G, pray the carburetor catches. But I have confidence in Miss Shilling's work. She's saved more pilots than any squadron leader I know. Parker climbed into his Spitfire at 7:15 in the morning. The aircraft smelled like oil and cordite and stale cigarette smoke. Every fighter smelled the same, a mixture of mechanics' sweat and pilots' fear and yesterday's combat. The ground crew had painted a scoreboard under his canopy. 6 confirmed kills, 3 probables, 2 damaged. Not bad for 9 months of combat. Not good enough to feel safe. He strapped in, ran through pre-flight checks. Fuel tanks, both full. Oil pressure, building as the engine warmed. Coolant temperature, climbing steadily. Magnetos, firing on all 12 cylinders. Oxygen system, flowing properly. Gun sight, calibrated and illuminated. Radio, crackling with mode. Static, but functional. Everything looked good. The ground crew chief, a sergeant named Williams, who'd been keeping Spitfires flying since 1937, climbed up on the wing. "She's ready, sir. Fresh ammunition, full fuel, and that magic washer the lady from Farnborough installed. You take care of my girl, she'll take care of you." Parker nodded. "Always do, Williams. See you in a few hours." "Counting on it, sir." Squadron leader Michael Robinson led the formation off the runway at 7:28. 12 Spitfires in 3 flights of 4. Parker flew as Tango 3, second flight, third position. They climbed to 15,000 feet, formed up over Warmwell, headed south toward the channel. The weather was perfect. Clear skies from horizon to horizon, unlimited visibility, light winds from the west, good hunting weather, bad weather for German bombers trying to sneak through. The Royal Air Force had learned early in the war that clear weather favored the defender. You couldn't hide bombers in bright sunshine, couldn't approach undetected when visibility stretched for 50 miles. They crossed the coast at 7:46. The white cliffs of Dorset dropped away behind them. Ahead lay the channel, steel-gray water stretching to the horizon. Parker checked his fuel gauges, both tanks showing full. He had maybe 90 minutes of flying time before he'd need to turn back. Less if combat got intense. The Merlin engine burned fuel like a furnace at full power. The controller's voice crackled over the radio at 7:53. "Tango leader, this is Warmwell Control." Bandits bearing 180, range 30 miles, altitude 12,000 feet, large formation, bombers with fighter escort. Vector 185 to intercept. Robinson acknowledged immediately. "Roger, Warmwell Control. Tango Squadron copies. Bandits bearing 180, range 30 miles. We're hunting." Parker scanned the sky ahead. At first, nothing but empty blue and the glare of, quote, morning sun. Then he saw them, dark shapes against the pale horizon. 18 bombers in loose formation, surrounded by Messerschmitt fighters weaving above and around them like sheepdogs protecting their flock. Standard German tactical formation. The bombers flew straight and level, maintaining tight enough formation for mutual defensive fire, but spread enough to avoid collision if fighters attacked. The Messerschmitts provided flexible defense, ready to intercept any threat from any angle. Robinson's voice came over the radio, calm and professional. "Tango Squadron, visual contact on bandits. 18 bombers, looks like Heinkels. 20-plus fighters, definitely 109s. We're going after the fighters first. Break them up, the bombers are easy meat. Attack on my mark." Parker felt his heart rate increase. Not fear exactly, more like anticipation. The moment before combat when everything sharpened, when time seemed to slow down, when instinct took over and training became reflex. "Tango Squadron, check your weapons," Robinson continued. "Safety off, gun sight on. Remember your briefing. Hit them fast, hit them hard. Don't give them time to coordinate." Parker flipped the safety cover off his gun button. His thumb rested on the firing stud. 8 machine guns armed and ready. 2,600 rounds waiting to reach out and touch a German fighter. 3, 2, 1, mark. 12 Spitfires dove as one. The formation that had been neat and professional 60 seconds ago dissolved into individual aircraft, each pilot selecting his own target, his own approach, his own killing ground. Robinson targeted the lead element of Messerschmitt's, 4 fighters flying top cover. Parker followed, his finger on the gun button, his eyes tracking the target, and that's when it happened. The thing that should have killed him. Parker pushed the stick forward. The Spitfire's nose dropped. Negative G-forces lifted him against his harness. For 1.5 seconds, he was weightless, and the engine kept running. Full power, no hesitation, no flooding, no carburetor failure. Parker didn't have time to think about it. He was diving at 400 miles per hour, closing on a Messerschmitt that hadn't seen him yet. He centered the gun sight on the German fighter's fuselage, led it slightly to account for deflection, and squeezed the trigger. 8 Browning machine guns opened up, 64 rounds per second. Armor-piercing, incendiary, tracer. The stream of fire converged on the Messerschmitt at 300 yards. Parker saw strikes on the wing root, the engine cowling, the cockpit canopy. The German fighter exploded, not a gradual fire, an instantaneous detonation. The fuel tank must have taken a direct hit. Pieces of aircraft tumbled through the sky. The pilot never had a chance to bail out. Parker pulled up, banked right, scanned for threats. The sky had turned into chaos. 12 Spitfires versus 20 Messerschmitts. Fighters twisting, diving, climbing. Tracers crisscrossing empty air. Smoke trails from damaged aircraft. He saw Robinson engaging 2 Messerschmitts simultaneously. Brilliant deflection shooting. 1 German fighter fell away smoking. He saw Flight Lieutenant Davies, no relation to Squadron Leader Davies from Kenley, diving on a Messerschmitt from directly above. Perfect bounce. The German never saw it coming. And he saw something else. Something that made him key his radio immediately. Tango Leader, this is Tango 3. The boys are pressing attacks they would have aborted, diving through negative G. Engines aren't cutting out. Robinson's voice came back, excitement barely controlled. I noticed. Keep it up. We've got them off balance. For the first time in 11 months, Royal Air Force fighters had the initiative. For the first time since the Battle of Britain started, British pilots could dive on German fighters without their engines betraying them. For the first time, the Messerschmitts were the ones reacting, defending, trying to survive. Parker spotted another target, a Messerschmitt climbing hard, trying to regain altitude advantage. Standard German tactic: get above the enemy, control the engagement. Not today. Parker rolled inverted, pulled the stick back, and dove. His Spitfire dropped like a stone. The engine roared at full power. He closed from 2,000 feet to 500 feet in 4 seconds. The Messerschmitt pilot saw him coming, tried to brake right, too late. Parker fired a 2-second burst. The German fighter's tail section disintegrated. The aircraft tumbled end over end, completely out of control. Parker saw the pilot bail out, parachute blossoming white against the blue sky. 2 kills in 3 minutes? Parker had never achieved that before. Hell, nobody in 609 Squadron had achieved that before. The restrictor wasn't just fixing a problem. It was giving them an advantage. Robinson's voice again. Tango Squadron, reform on me. The bomber formation is breaking up. Let's finish this. The 18 Heinkel bombers had indeed scattered. Without fighter protection, without any realistic defense, they were jettisoning their bombs and running for France. Some were already descending, trying to get low where Spitfires would have trouble catching them. Parker rejoined formation with Robinson and 5 other Spitfires, 6 aircraft remaining from the original 12. He didn't know where the others had gone. Shot down, damaged, and returning to base, chasing individual targets. They caught up with the bomber formation at 10,000 feet, 30 miles south of Portsmouth. 8 Heinkels still in loose formation, 4 more scattered to the east and west. Robinson keyed his radio one more time. Gentlemen, time to show them what Spitfires can do when our engines work. Attack at will. What happened next became legendary in fighter command. 6 Spitfires dove on 8 bombers. No tactics, no coordination, just pure aggression. Parker, picked the lead Heinkel, closed to 200 yards, opened fire. The bomber's port engine exploded. The aircraft rolled left, fell away smoking. He pulled up, looked for another target, saw Davies engaging a Heinkel from the beam. Perfect 90-degree deflection shot. The bomber's starboard wing crumpled. The aircraft spiraled toward the channel. Robinson destroyed 2 bombers in 30 seconds. Just walked his fire from one to the next, like he was shooting targets on a range. His ammunition discipline was perfect. Short bursts, aimed shots, 2 kills, maybe 400 rounds expended total. In 4 minutes, 6 Spitfires destroyed 12 German aircraft, 8 Heinkels, 4 Messerschmitts. The remaining bombers fled toward France at wave-top height, jettisoning everything that added weight. The surviving Messerschmitts followed them, no longer attempting to engage. Parker checked his fuel. Half tanks. Ammunition almost depleted. His hands were shaking from adrenaline. He'd fired his guns more in the past 4 minutes than in the previous 6 weeks combined, and his engine had worked perfectly. Every dive, every negative G maneuver, every moment when the carburetor should have flooded and left him defenseless, the restrictor had worked. They landed at Warmwell at 8:47. 62 minutes from takeoff to landing. The ground crews swarmed the aircraft, counting bullet holes, checking damage, refueling and rearming for the next mission. Parker climbed out of his cockpit. His flight suit was soaked with sweat. His mouth tasted like copper and smoke. He lit a cigarette with shaking hands and walked toward the dispersal hut. Robinson was already there, talking to Group Captain Harris, the station commander. Parker caught the end of the conversation. 12 confirmed kills, sir. 8 bombers, 4 fighters. 0 losses on our side. 3 aircraft damaged, all repairable. It's the restrictor. Has to be. We've never achieved results like this before. Harris nodded slowly. I'll call Air Ministry. They need to know this modification isn't just preventing failures. It's changing the tactical equation. And that's exactly what happened. By April 1941, every Hurricane and Spitfire in Fighter Command had the restrictor installed. Not just to prevent engine failures, to give British pilots the confidence to press attacks they would have aborted before, to eliminate the psychological advantage German fighters had maintained since the Battle of Britain began. The statistics told the story. March 1941. Before widespread restrictor adoption, Royal Air Force fighters reported engine failures in 38% of diving attacks against German aircraft. April 1941. After the restrictor, engine failures during diving attacks dropped to 0.4%, almost non-existent. The kill-to-loss ratio improved immediately. March had been brutal. Fighter Command lost 47 Hurricanes and Spitfires in combat, shot down 61 German aircraft, a ratio of 1.3 to 1, barely breaking even. April was different. 29 British fighters lost, 94 German aircraft destroyed, a ratio of 3.2 to 1. The restrictor wasn't the only factor, but squadron commanders credited it as a major contributor. Pilots reported increased confidence in combat. They pressed diving attacks without hesitation. They committed to aggressive tactics that would have been suicidal a month earlier. Flight Lieutenant Robert Stanford Tuck flew Spitfires out of Duxford. He'd experienced engine failure 4 times before the restrictor. After installation, he destroyed 3 Messerschmitt Bf-100 in 9 seconds in May, 2 more in June. He credited the restrictor with giving him the confidence to commit to aggressive tactics. All right, quick pause here. If you're finding this story as incredible as I am, hit that subscribe button, because this is the kind of history they don't teach in schools. This is the real stuff. The brass tacks, nuts and bolts, life and death engineering that won the war. And if you want more stories like this, stories about the people who did the impossible with nothing but determination and a 50-cent piece of metal, this channel is for you. Subscribe so you don't miss what comes next. The modification spread beyond Fighter Command. Royal Air Force Coastal Command requested restrictors for their Beaufort fighters. Bomber Command wanted them for training aircraft. Even the Fleet Air Arm inquired about installation on carrier-based fighters. Beatrice coordinated production with Rolls-Royce. By June 1941, they were manufacturing 1,000 restrictors per week. But here's what most people don't know. The restrictor did more than just fix the carburetor problem. It changed pilot psychology. Before the restrictor, British pilots approached combat cautiously. They knew their engines might fail at the worst possible moment. They hesitated, they second-guessed. They avoided certain maneuvers because the risk was too high. After the restrictor, that caution disappeared. Pilots trusted their aircraft. They committed to attacks without reservation. They exploited openings that would have been too dangerous before. The confidence factor was as important as the technical fix. German pilots noticed immediately. Luftwaffe after-action reports from May 1941 consistently mentioned the change in British fighter tactics. One report stated, British fighters now press diving attacks with aggression previously unseen. Engine reliability appears to have improved significantly. Previous tactical advantage has been neutralized. Another report from June. Recommendation to avoid direct stern engagements with Spitfire and Hurricane aircraft. British pilots demonstrate increased willingness to maneuver aggressively during combat. Fuel mixture problems previously observed appear to have been resolved. The Germans didn't know about the restrictor. They didn't know about Beatrice Shilling. They just knew that British fighters had suddenly become much more dangerous. The restrictor remained in service through 1943. Rolls-Royce finally introduced the pressure carburetor in January 1943. The new carburetor eliminated the negative G problem completely. It used fuel injection principles similar to German engines. No float chamber, no flooding, perfect fuel delivery under any flight condition. But converting existing aircraft to pressure carburetors required extensive modifications. Remove the old carburetor, install new fuel pumps, rewire engine controls. Each conversion took 8 hours. During those 8 hours, the aircraft couldn't fly combat missions. Fighter Command couldn't afford to ground squadrons for extended maintenance, so they kept the restrictors. Many aircraft flew with Miss Shilling's orifice until 1944, some until the end of the war. New production Spitfires and Hurricanes received pressure carburetors, but older aircraft kept their restrictors. Pilots trusted them. Ground crews knew how to maintain them. If it worked, don't change it. Beatrice moved on to other projects. She worked on cold weather starting systems for engines in Iceland and Russia. She researched high-altitude fuel mixture problems. She helped design improved supercharger systems for late-war Merlin variants. The Royal Aircraft Establishment kept her busy with dozens of technical challenges. But the restrictor remained her most famous contribution. Pilots remembered it. Engineers studied it. After the war, aviation schools taught it as an example of elegant problem-solving under pressure. Simple solution, immediate implementation, measurable results. Everything good engineering should be. Keith Maddock, chief engineer at the Royal Aircraft Establishment during the war, said it years later, Beatrice Shilling helped us win World War II. Of that, there is no doubt. The restrictor was a war-winning modification. Let me tell you about Beatrice's personal life, because it matters. She married George Naylor in September 1938. He worked at the Royal Aircraft Establishment as an aerodynamicist. When war started, he volunteered for Royal Air Force Bomber Command. He flew Avro Lancasters with 625 Squadron 31 combat missions over Germany. He earned the Distinguished Flying Cross for completing an extra tour beyond his required missions. Beatrice worried about him every time he flew. She understood bomber loss rates. Bomber Command suffered higher casualties than any other Royal Air Force branch. 1 in 2 bomber crew members didn't survive the war. George beat those odds. He survived his tours and returned to Farnborough in 1944. They never talked about his missions. He never asked about her projects. They kept work and marriage in separate compartments. Beatrice continued racing motorcycles when time permitted. She'd stopped racing at Brooklands when war started. The famous circuit had been converted to aircraft production facilities, but she still rode her Norton. Fast riding helped her think, solve problems that laboratory work couldn't crack. Some of her best engineering ideas came while riding at 90 miles per hour on country roads. By 1945, she'd worked on 17 major projects at Farnborough. Cold weather systems, high-altitude modifications, carburetor improvements, fuel mixture optimization, supercharger efficiency upgrades. Each project saved lives. Each project kept Royal Air Force aircraft operational under extreme conditions. But none achieved the fame of the restrictor. The war ended in May 1945. Germany surrendered. Japan followed in August. The Royal Aircraft establishment transitioned from wartime emergency projects to peacetime research. Slower pace, lower urgency, different priorities. Beatrice stayed at Farnborough. She had no intention of leaving. Engineering was her life. In 1948, she received official recognition for her wartime contributions. King George VI appointed her Officer of the Order of the British Empire. The OBE ceremony took place at Buckingham Palace. Beatrice wore her formal dress, accepted the medal, posed for photographs, then went back to work at Farnborough the next morning. She never stopped engineering, never stopped solving problems, never stopped proving that women belonged in technical fields. Her career at the Royal Aircraft Establishment continued for another 21 years. She never reached the top administrative positions. Those roles were reserved for men. The Royal Air Force leadership structure didn't promote women to director-level posts, regardless of accomplishment. Beatrice accepted this limitation. She preferred hands-on engineering work anyway. Laboratory testing, field modifications, real problems with real solutions. Her post-war projects included the Blue Streak missile program, Britain's first ballistic missile. Beatrice worked on fuel delivery systems and high-altitude performance. She researched wet runway braking effects for jet aircraft. Landing accidents killed more pilots than engine failures by the 1,950 seconds. Understanding how water on runways affected tire friction could save lives. Beatrice published 3 technical papers on the subject. She even helped design a bobsled for the Royal Air Force Olympic team. Strange project for an aeronautical engineer, but bobsled design involved aerodynamics, weight distribution, and friction management, skills Beatrice had mastered over 30 years. The Royal Air Force team used her bobsled design in competition. They didn't win medals, but they didn't crash either. Beatrice retired in 1969 at age 60. She spent retirement restoring vintage motorcycles, racing occasionally at classic motorcycle events, maintaining her Norton. She'd kept the same motorcycle since 1934. The machine she'd raced at Brooklands, the machine that had taught her how engines behaved under extreme stress. She died on November 18th, 1990. Age 81, survived by her husband George and a lifetime of engineering achievements. The obituaries in British newspapers focused on the restrictor, the brass washer, Miss Shilling's orifice. Everything else she'd accomplished was footnotes. Now, before we wrap this up, let me ask you something. If this story moved you the way it moved me, if you're sitting there thinking about this woman who saved 3,000 pilots with a 50-cent piece of metal, do me a favor, hit that like button. Share this video with someone who needs to hear it, because these stories matter. These people deserve to be remembered. And your engagement, your likes, your shares, that's what keeps these stories alive. That's what tells YouTube to show this to more people. It's that simple. One click makes a huge difference. Her legacy lived on in unexpected ways. In 2011, a pub in Farnborough was renamed the Tilly Shilling. The Brooklands Museum purchased her racing trophies and badges in 2015. Winchester Heritage celebrated her in 2018 as one of Hampshire's extraordinary women. In 2019, Royal Holloway University opened the Beatrice Shilling Building for electronic engineering students. On March 8, 2019, the mayor of Waterlooville unveiled a plaque at the local library. 110 years after her birth, the restrictor itself became a teaching example. Engineering schools worldwide studied it. Simple solution to complex problem. Immediate implementation under wartime pressure. Measurable, life-saving results. Everything good engineering should achieve. Some universities kept original restrictors on display. Small brass washers in museum cases. Reminders that elegant solutions don't require complexity. Let me tell you why this story matters. Why you should care about a woman who died 33 years ago. Why a 50-cent brass washer deserves an hour of your time. Because Beatrice Shilling represents everything that's right about engineering. She saw a problem. She understood the physics. She developed a solution. She tested it. She implemented it without waiting for permission. She saved 3,000 lives. No bureaucracy, no committees, no endless meetings. Just one woman with a toolbox and a motorcycle, refusing to let her boys die. That's the kind of person we need to remember. That's the kind of story we need to tell. Because in a world of overcomplicated solutions and bureaucratic delays and people who talk instead of do, Beatrice Shilling stands as a reminder that sometimes the best answer is the simplest one, a brass washer. 50 cents, 3,000 lives saved. Think about Flight Lieutenant James Parker, March 23, 1941, diving on a Messerschmitt at 400 miles per hour. His engine should have quit, should have left him defenseless, should have gotten him killed, but it didn't, because 2 weeks earlier, a woman he'd never met installed a brass washer in his fuel line, without permission, without authorization, without knowing if it would work. Parker survived the war, flew 93 combat missions, destroyed 14 German aircraft, earned the Distinguished Flying Cross and Bar, lived to be 87 years old, died in his sleep in Devon, surrounded by family. He never met Beatrice Shilling, never knew her name until after the war, but he owed her his life. So did Squadron Leader Robinson, so did Flight Lieutenant Davies, so did 3,000 other pilots who climbed into Spitfires and Hurricanes with Miss Shilling's orifice in their fuel lines. The Battle of Britain was won by brave pilots. Nobody disputes that. But it was also won by brilliant engineers. By people like Beatrice Shilling, who refused to accept that young men should die from preventable problems, who worked 16-hour days to find solutions, who risked their careers to implement unauthorized modifications, who measured success not in praise or recognition, but in lives saved. Conservative estimates credit the restrictor with saving 300 Royal Air Force bombers and 3,000 aircrew over the course of the war. That's not counting the German aircraft destroyed because British fighters could finally press attacks without their engines failing. That's not counting the missions that succeeded because pilots had confidence in their equipment. That's not counting the psychological impact on German fighter pilots who suddenly lost their tactical advantage. The compound effect of Beatrice Shilling's work rippled through the entire air campaign over Europe. After the war, military historians studied her methods. The principle of simple solutions to complex problems became incorporated into engineering doctrine for multiple nations. Soviet Union, Britain, even Germany, in post-war analysis, acknowledged the effectiveness of the restrictor. The concept spread beyond aviation. Wherever defensive systems needed improvement, engineers remembered Beatrice Shilling's brass washer. Sometimes the best solution isn't the most complicated one. Sometimes genius looks like a 50-cent piece of metal welded into a fuel line. Let me give you some final numbers. Numbers that tell the real story. March 1941. Royal Air Force Fighter Command, 1,847 operational aircraft. Engine failure rate during combat, 38%. Pilot confidence level, measured low by post-combat interviews. Kill-to-loss ratio, 1.3 to 1. German tactical advantage, significant. June 1941. Royal Air Force Fighter Command, 2,103 operational aircraft. Engine failure rate during combat, 0.4%. Pilot confidence level, measured high. Kill-to-loss ratio, 3.2 to 1. German tactical advantage, neutralized. The difference? 3,000 brass washers. One woman's refusal to accept failure. 50 cents of metal that changed the war. Beatrice Shilling never thought she was a hero. When journalists interviewed her in the 1,980 seconds, she deflected praise. "I did my job," she said. "The pilots did the hard part. I just gave them equipment that worked." But squadron leader Michael Robinson, the man who led 609 Squadron on that March morning, disagreed. In a 1987 interview, he explained Beatrice's impact. "Before the restrictor, we flew scared. Scared our engines would quit at the worst possible moment. Scared we'd die from a mechanical failure instead of enemy action. Beatrice gave us confidence. She gave us reliable aircraft. She gave us the ability to fight on equal terms. That's what won the air war over Europe. Not bravery, not tactics, confidence in our equipment. And we got that confidence from a woman in a workshop who refused to let us down." Flight Lieutenant James Parker said it more simply in 1990, just months before Beatrice died. "She saved my life. Saved it without ever meeting me. Saved it with a piece of brass she machined herself. I owe her everything. We all do. So here's my challenge to you. The person listening to this right now, think about the problems you face, the obstacles that seem insurmountable, the challenges that everyone says can't be solved. Think about Beatrice Shilling, 32 years old, standing in a workshop in 1941, machining brass washers while her country fought for survival. She didn't have unlimited resources. She didn't have a big team. She didn't have permission. She just had a problem that needed solving, and the determination to solve it. That's the lesson here. That's why this story matters. Not because of the brass washer, because of the mindset. The refusal to accept that things can't be fixed. The willingness to risk everything on a simple solution. The courage to implement changes without waiting for approval. Beatrice Shilling changed the world with a 50-cent piece of metal. What could you do if you stopped waiting for permission? All right, final thing before we wrap up. If this video meant something to you, if you're walking away from this thinking about Beatrice Shilling and those 3,000 pilots she saved, I need you to do two things. First, hit that subscribe button, because we make videos like this every week. Real stories, real heroes, real history. The stuff they don't teach in schools. The people who deserve to be remembered. Second, drop a comment and tell me where you're watching from. Are you in Texas? California? Maybe you're overseas? I want to know, because this community stretches around the world. You're not just a viewer. You're part of keeping these memories alive. You're part of making sure people like Beatrice Shilling don't disappear into history. So tell me your location. Tell me if someone in your family served. Tell me what you think about this story. Just let me know you're here. Thank you for watching. Thank you for caring about the real heroes of World War II. And thank you for making sure Beatrice Shilling doesn't get forgotten. She deserves to be remembered, and you're helping make that happen.